Alright guys, we got one heck of a project we're working on. Really excited about that. And that is the high idle controller, and more specifically the stage 6 unit. We did some playing around with this, designed the board a while back. We sent the boards in to get made a little over a month ago, but I tried to order before. They had this Chinese festival going on, whatever, and they put it on the website that if you order before X date, they should be able to get them made before then. So which case the shipping time would be the normal 1 to 2 weeks. But if we ordered after that, then it would take a lot longer, because I think it's a 2-week long festival or whatever. So I sent the boards in on time, but apparently it did not didn't pass their automated board testing, their software or whatever, for making sure the board is a legitimate design. So they had to do it manually, and that of course delayed it to after their festival, so I had to wait the full month or so. We also got electrical components, got these in the mail a while back, because they did not take a month to get here. Enclosures, connectors, buzzers, and whatnot, and then microcontrollers, diodes, and all those little things that you never want to have to deal with, all that stuff. And that is of course for the stage 6 unit. We're going to be assembling those later in a different video. For now, I just want to explain the other renditions, what has we gone through in order to get to stage 6, because there's obviously been 5 other stages before that one. So in order for all that to make more sense, I wanted to explain the other ones and some of the changes between them all and why we did what we did. So the first rendition was a complete and utter failure. The only thing that did was take a cold engine and rev it to 2500 RPM. So I think I got a video of that, so I'll put that in end of this video if I do indeed have that. The second rendition was a success, a great success. You guys, I put a video on YouTube about a year ago showing it off, showing it work, and I made an article on how to make that stage 2 system. You have your enable switch, and you got your raise and lower switch. That worked really well. Like I say, I got a YouTube video for it. I got a link around here somewhere. I watched a YouTube on how to do this. So let's see if we can get this straight. Okay, here we go. Like that. And we get the video like this. So that should be the video. And then put a link on it like that. So that should be a link right there. So you can click that. And then to erase it, we just go like this. Like that. Okay, so hopefully that worked. If I read that YouTube video correctly, that means it should have worked. I guess I watched the YouTube video correctly. How do you watch it? Anyway, that was stage 2 unit. The stage 3 unit, what it did, because with the stage 2 you had to remove the slack out of the cable for a bit, and then once you remove the slack out of the cable, it was very touchy. So it was kind of easy to overshoot while you're trying to take the slack out of the cable. So what stage 3 unit was basically a little switch that down in the engine that once the throttle moved just the slightest amount, it would let this thing know, and then so that way it would apply the throttle until the slack out of the cable was taken up, and then it would let off the throttle. The problem with that was it overshoot it big time. Really way overshoot it, again, 2500 RPM on a warm engine, because I learned my lesson from last time. So that was I could have made that work with a 555 controller, little bit of circuitry there, but I decided to go for the full swing, and that brought us to stage 4, which gave us a microcontroller in there so we could really fine-tune our control over it. And that is the user interface changed from those 2 buttons and a switch to just a knob. So you turn the knob one way to increase the throttle, turn the knob the other way to decrease the throttle, and then you just hit the knob because it had a built-in button to it. So you just hit the knob once to enable it, and hit it again to disable it. Really clean user interface. Also gave us an LED and a buzzer, just a little bit of a user feedback. Excuse me, whatnot. Anyway, that really helped, and with that I could automatically apply a little bit of throttle when you enabled it, which would take the slack out of the cable. It worked really well, but that all was just a temporary system in order to get a stage 5 unit. Now, stage 5 unit is the same hardware as stage 4, but it has a RPM sensor input for the controller. So it can read the engine RPM, which then allows us to aim for a certain RPM when I enable that switch. So when I turn on the switch, I hit the button, it automatically takes it up to whatever RPM we have it set at. In our case, we have it set up for 1200 RPM. And what's really cool about that is it also has load sensing. So, and that's what really pushed me over the edge with to do this design of the chip. Between that overshooting with cold, with having to do the buttons and whatnot, and then there was the other thing was when you had actually two things. First of all, when you start up on a cold engine, you hit the throttle, you bring it up to, let's just say, 1000 RPM. Well, as the engine warms up and things become looser and spin a little easier, the RPMs would increase slowly, which just not a big deal, but I'm kind of whatever, I nitpick a little bit too much. So that obviously would fix that with the load sensing. It would detect the RPMs coming up and decrease throttle. And then the other thing that really just pushed me over the edge was I had an OBA system, an onboard air system, basically an air compressor hooked up to the engine. That way I could fill up tires and whatnot. So I was filling up tires, whatever. I had it enabled, so it was giving me about 1200 RPM. But when the AC compressor kicked on, actually it's an AC compressor, but we're using it as an air compressor. When the air compressor kicked on, the RPMs dropped to about 900 or so, which is next to pointless because idling with the AC compressor on or the air compressor on, it's like 825. So I gained about 75 RPM with having the high idle enabled. But then when the AC compressor kicked off again, air compressor, it kicked off again, the RPM shoot up to 1200 or so. It was really just pushed me over the edge to have something that could be load sensing. So really excited about that. That's the stage 5 unit. It was supposed to be the last and final stage and be the greatest thing since sliced bread, but I made a couple mistakes. The main one, which really pushed me over the edge to make the stage 6 unit, was that I thought I was being overkill with the protection circuitry for the RPM signal, because the RPM signal is a 0 to 5 volt sensor, which would be completely safe to put into the microcontroller, but I wanted to be able to, if something went wrong, I didn't want to fry the microcontroller, so I wanted to have some protection there. So I put this chip in line to be able to intercept the signal and then send a new signal, replicate of the signal to that microcontroller. That way, that little chip there was supposed to be a lot more robust and whatnot. The specification said it would be good to minus or positive 32 volts, so negative or positive 32 volts going in, and all our little microcontroller would only see 0 to 5 volts. So it was supposed to be the be-all end-all of protection circuitry for this guy. Well, I misreading the fine print, so that was only under a certain condition that we weren't meeting, and so it was actually only rated from 0 to 3.5 volts, and because, like I say, the signal is 0 to 5 volts, so it didn't treat it that well. I ended up frying a couple before I figured out what was going on, so I could have possibly made do, but I decided, you know what, we're going to do a new board, start from scratch on the board. And we added a couple extra features as well. Like I say, we had a buzzer before. Well, first of all, this protection circuitry, we went with a whole new design with that. We basically did it manually with diodes and resistors. Instead of getting a chip that's supposed to do it, we just did it with like other components like diodes and resistors. That should be able to withstand the mains, or positive, negative 144 volts. I'm not going to try it. Actually, I might try it for you guys just for grins, but I wasn't planning on trying it. I'm not sure I'm looking forward to it, but it should be able to do it, and it should be able to, there's also a couple of features it has. It has the buzzer again, same buzzer, but with the circuitry we added, it's volume adjustable, so we can have like 10 stages of volume adjustability, so that way you can set how loud you want that buzzer to be. It's enclosure friendly. We got some holes in there to be able to mount it in the enclosure. We also changed up the connectors because I didn't like the certain model connector I was using. And we added a bi-color LED. So right now I have just a little green LED, and so it's on and off. So with this one, it's a bi-color red and blue. So blue can be your normal everyday color. Yes, everything's going great. You know, it's blue. That means everything's wonderful. And then red can say, okay, we noticed something's wrong, or give us a little bit more options in our user interface. Another way of communicating to the user. Because right now, there's a bunch of options on the Hiota controller that you can switch through, but the user interface is kind of complex because all you've got is a knob, a button, an LED, and a buzzer. and there's so many things that you can change, and I'd like to be able to change more functions I'd like to add. I don't remember the full list, but right now we have LED brightness, we have buzzer volume adjustability, or actually no, it's just right now it's just on and off, but we're going to change that to complete adjustability, like 10 different stages. Another thing is how touchy your throttle is, or how much, when the controller sees a certain amount of deviation in the throttle, how much throttle, or a certain deviation in the RPM, how much throttle should it give the engine in order to like increase the throttle again back to your 1200, or decrease it again, like whether you take load on or off the engine. How touchy the throttle is basically is what that would do, because like some of these guys with 4K governor spring kits, the throttle can get really touchy. Bigger injectors, it can get quite, or delivery valves, it can get quite touchy to where you want just small changes, otherwise it's going to overshoot. Or a guy with a stock truck would want something that's a lot more reasonable, because you know, stock obviously has a much smoother throttle input, especially down low, because with the governor springs that really tends to make a very touchy RPM down low, and you know, sub 1200, which is basically where this guy operates. So there's those couple things. There's also a couple other things. You can calibrate the RPM of your sensor. So if you're using the stock sensor, you can just leave it, or you can calibrate it to that. I'm not going to go into how to do that. That's kind of complicated. You can also read the RPM. It'll display the RPM that the controller is seeing via the LED flashing. There are multiple other things that you should be able to switch through, and so a better user interface would make that easier. So hopefully a bicolor LED will help with that a little bit. And I'm sure there are other things that we changed. Oh yeah, we also added more, we made it so it can fit in the enclosure, so we had to make it slightly smaller, but we had added more expandability via some headers on it, so you can stack another board over top of it. So a bunch of other stuff we added with the Stage 6 unit. So we're going to be assembling that at some point in time, hopefully in the next couple days, and then we'll have to do a bunch of programming and whatnot, make it so it'll work, because right now I only got the programming for the Stage 5, which of course will not work in the Stage 6 based on the couple of changes we have, and even if it did, there are a couple things that we want to be able to utilize, like that bicolor LED and the volume adjustability. So I'll have to do some changing there, code, and then play around with the connections here, because the board connectors are different, but we'll do all that stuff. Hopefully I can take you guys with that whole process, just so you can kind of see what's involved, and hopefully we will have a working high idle controller. So thanks for watching. I hope the new videos will be coming out here soon. I'd love to hear from you guys, comments. Let me know what you think, and remember, keep wrenching, even if it's with these little things that are so miserable to work with. Actually, it's more in here. I mean, even if you're wrenching with these guys, these diodes or resistors or the microcontrollers, it all counts as wrenching. If you're making something, you are wrenching. If you're cooking, I'm not sure that might count. You know what? Yes, that counts. If you're cooking, that counts as wrenching too. If you're doing anything cool, that counts as wrenching. So take care.
Oh, I think I got it rigged up wrong.